Hi sir, this is Madesh. Now I am going to explain about flow calorimetry and enthalpy calculation. The flow calorimetry is defined as it is an experimental technique which is used to determine the change in temperature or enthalpy, change in enthalpy in a continuously flowing fluids. The flow calorimetry experiment is discovered in the time period somewhere around 1940 to 1950. It is not only discovered by the single person, there are so many scientists involved in the discovery of flow calorimetry. This is a schematic representation of a flow calorimetry experiment. Then calorimeter. Calorimeter is a device which is used in the calorimetry flow calorimetry experiment, which is used to determine the change in temperature. Means enthalpy. The calorimeter allows us to determine heat of the reaction, specific heat capacity, heat of fusion, or are also called as vaporization, enthalpy of combustion. Heat of the reaction means calorimeter measures the heat produced during a chemical reaction. Then specific heat capacity. It is the amount of heat required for unit mass to raise its temperature by 1 degree Celsius. Then vaporization. The amount of heat required to convert 1 mole of liquid water into vapor water. Then enthalpy of combustion. It is defined as the amount of heat required to convert the 1 mole of substance into ashes. Calorimeter works on the principle called law of conservation of energy. Means energy neither be created nor be destroyed. It can convert from one form to another. In terms of it, uh, we can also call as we can also say this as heat lost by the body is equals to heat gained by the environment. There are so many calorimeters. Now we are considering only four of these. There are which are coffee cup calorimeter, bomb calorimeter, and flow calorimeter, and differential scanning calorimeter. This is a representation or schematic diagram of coffee cup calorimeter. This is a schematic diagram of bomb calorimeter. Uh, this is the diagram which represents the flow calorimeter. Flow calorimeter. This is a schematic representation of differential scanning calorimeter. Calculation of enthalpy. The main formula involved in the calculation of enthalpy is delta H is equals to m into Cp into delta T divided by n, where delta H is change in enthalpy, m is mass of the substance, Cp is specific heat capacity, delta T is change in temperature, n is number of moles of the substance reacted during the reaction. The units of delta H is kilojoule per mole, and units of mass we can measure this in grams or kilograms. Then units of specific heat capacity is joule per kg Kelvin. Change in temperature measured in Kelvin, and number of moles measured in moles. Now we are going to see the problems on enthalpy. The problem number one is stated as 500 grams of water in a coffee cup calorimeter increased in temperature from 25 degrees Celsius to 28.5 degrees Celsius, where an acid and base reacts. We have to calculate change in enthalpy if 0.05 mole of water is formed. In the question, delta T is given and mass of the substance is given. Then number of moles formed during the reaction is given. We have to calculate enthalpy by using the formula delta H is equal to Q by N, where Q is amount of heat absorbed or released during the reaction. Here temperature is in degree Celsius. We have to convert into Kelvin. The delta T is 3.5 degree Celsius. In Kelvin, it is 276.65 Kelvin. Then we have to calculate Q. Q is equals to m into Cp into delta T. Then we have to calculate number of moles, but number of moles was directly given. Then we have to substitute in the main formula. Then we will get the solution in negative terms because the overall reaction is exothermic in nature. Then problem 2 is stated as when 6 grams of NaOH is dissolved in 100 grams of water, the temperature of the solution rises from 25 degrees to 31.9 degrees Celsius. We have to calculate change in enthalpy. The mass of the solution is 106 grams. In the solution, in the problem, change in temperature is 6.9 degrees Celsius. In Kelvin, it is 280 Kelvin. The mass of the substance used during the reaction is 106 grams. Here we have to calculate heat absorbed or released during the reaction individually, and we have to calculate number of moles of the substance formed during the reaction, and we have to substitute the value in the main formula, which is delta H is equals to Q by N. Q is equals to M into Cp into delta T. Then N is weight of the substance divided by molecular weight of the same substance. It will give the number of moles formed during the reaction. Then we will get the final solution in negative terms because the overall reaction is exothermic in nature. Problem 3 is stated as the flow calorimeter. In a flow calorimeter, a solution of mass 0.12 kg passes through a container of specific heat capacity 4.18 into 10 power 3 joule per kg Kelvin and experiences the temperature change of 2.3 degrees Celsius. And calorimeter itself absorbs the heat equivalent to 350 joule per Kelvin if 0.025 mole of the substance reacted. We have to calculate change in enthalpy. Delta H is equals to Q by N, which is the main formula. Here we have to calculate heat absorbed by the solution and heat absorbed by absorbed by the calorimeter, and then we have to calculate number of moles formed during the reaction. Normal heat absorbed by the solution is equals to M into Cp into delta T, which was given in the question. Then we have to add heat absorbed by the calorimeter. It will give the total heat absorbed during the reaction, and we have to substitute that into the uh, final uh, final formula, which is delta H is equals to Q by N. Here also the overall reaction is in negative terms because the reaction is exothermic in where heat is released during the reaction. Sir, this is all about the flow calorimetry and enthalpy calculations. Thank you, sir.